Hello, geometry students. Today you are watching a video that goes over backwards volume problems. So what a backwards volume problem is that it means you're going to be given the volume and you're going to need to find a missing measurement. So either you're going to be finding the missing height of the solid, the missing base length, the missing base height, or even the radius of something with a circular base. So for the first problem, we are going to be finding the missing dimension. So we have a volume of 240 meters cubed, and it looks like we are looking at a prism. So I'm going to go ahead and put prism here, and the volume is the area of the base times the height. All right. Now, after I have filled this part in, I'm going to go ahead and look at what shape my base is. So looking at your base here, I see the missing dimension on this bottom piece right here. It looks like from the top to the bottom is 8 meters. So I am going to say, okay, if I have 240 here, my base area would be length times width, so 5 times S, and then the height is 8. So there's a multiply sign in there. It's just hard to see. So over here I have 240. I'm going to take 5 times 8 and have 40s. And then now I'm going to divide by 40 so that I can solve for s, that missing side there. So if you type in 240 and you divide it by 40, you will get your answer here to be 6, and your units are meters. So the missing side of that base is 6 meters. All right, so what I want you guys to do is pause the video here and see if you can try number 2 on your own, and then hit play when you're done and see how you did. All right, so for number 2, you were given a cylinder here. So the volume is going to be the area of the base times the height. Well, if you're talking about a cylinder, then the base is always found by taking pi times the radius squared. So I'm just going to go ahead and fill in pi r squared where the capital B usually goes. So for volume, I have 1,244 equals pi. My radius is 6 inches, so 6 squared times the height, which is t. That's what we don't know. All right, so I'm going to go ahead and let's type in pi times 6 squared here. So I got 1,244 equals 113.1 t. So then we'll divide by the 113.1. Cancels out over here. And t equals, so let's find out. So 1,244 divided by 113.1. Hit enter and you get, basically we're going to call that 11. So t would equal 11 for that one. All right, now we're going to do the similar process here, but we're going to be talking, again, it's more application sounding now. So a pyramid with a triangular base has a volume of 80 cubic centimeters and a base area of 20 square centimeters. We want to find the height of the pyramid. So the volume is 80. The base area was 20. We need to know the height. So our volume formula for a pyramid is 1/3 area of the base times the height. Well, we found the volume was 80. The base area is 20. Now we got the height. So let's figure out what 1/3 times 20 is. And you're probably going to get a decimal here. Sometimes you don't, sometimes you do. So we're going to go ahead then and round that. Let's call that 6.7. So now we'll divide by 6.7 on both sides. So 80 divided by 6.7 gives us approximately 11.9. And our units are centimeters. So the height is 11.9 centimeters. All right, number 4, you have a cylindrical trash can with a volume of 2,335.8 cubic inches, and they want you to find the diameter of the trash can if the height is 18 inches. So right here, volume equals 2,035.8. You're finding the diameter, which again is 2 times the radius. And then your height is 18 inches. So volume is capital B times H. So for volume, I'll plug in 2035.8. For capital B, I'll do pi times the radius squared, and then the height is 18. All right, so what I'm going to do before I do anything else is I'm going to take pi times the 18. So we get 56.5 there. So let's divide by 56.5. I've changed my color to yellow so you can read it a little bit better under this blue background here. So 2,035.8 divided by 56.5. We get 36. When you round to the nearest tenth, it's going to give you 36. So take the square root here because you had r squared and you want r, and you get the radius to equal 6. But they wanted the diameter, so now take 2 times 6, and the diameter of this trash can is 12. Our units are inches. So you had to go in a little bit of an extra step on that one. You found the radius, but you needed to know the diameter. All right, next question here. It says a triangular pyramid has a volume of 180 cubic centimeters and a height of 12 centimeters. The height of the triangular base is 6 centimeters. Find the base length. So don't judge me too harshly here. I'm attempting to draw a pyramid for you so you guys can visualize it. It's a lot harder to do on a tablet than on paper. So your height from here to here is 12. It says the height of the triangular base is 6, and they want to know what the base length is. So the volume of a pyramid is 1/3 area of the base times the height. So we have 180, because that's the volume. You have 1/3, and then to find the area of a triangle, you do 1/2 6 times b, and then your height is 12. Okay, so if we got a couple issues here, we have a fraction in the parentheses here, so let's kind of get rid of that. 1/2 of 6 is 3, so I have 3 times the base times 12. So now I'm going to go ahead and get out my calculator, and I'm going to type in 1/3 times 3 times 12. And that'll give me 12. So I have 180 equals 12 times the base. Now I can divide by 12 so that I can have just the base here. So I'm going to do the base equals, so 180 divided by 12. And you get 15. So the base length for that triangle is 15 centimeters. So I'm going to kind of repeat this because I don't know if I explained this very well. This right here is the area of a triangle. And the area of a triangle is 1/2 the base times the height. Well, you already knew the height of the triangle was 6. You needed to solve for the base. So that's where the 1/2 times 6 times b came from. The height of the pyramid was 12. So for that, I plugged in 12. And then all I did right here is I multiplied 1/2 times 6. So that's where that 3 came from. And then after that, I did 1/3 times 3 times 12. And that gave me 12 times b equals 180. And I solved for b from there. All right. Next problem here is talking about perimeter. So I want to make sure we talk about the concept of perimeter really fast. So perimeter means you have like a shape here. You have 4 sides. You add up all 4 sides, and that's how you do perimeter. Okay, so if like this was 7, 7, 8, and 8, I would do 7 plus 8 plus 7 plus 8. That would give me my perimeter. So that's just an example. For this number 6 here, it says the perimeter of the square base. Well, in a square, all 4 sides are congruent. So I'm just going to put S here. So the perimeter for a square is 4 times S, because S plus S plus S plus S is 4S. So the perimeter of the square base of a pyramid is 40 inches. The volume is 500 cubic inches. Find the height of the pyramid. Well, in volume, you need 1/3 the area of the base times the height. Well, we have the volume is 500. We don't know the area of the base, and we don't know the height. But the area of the base, especially if it's a square, is just the sides times the sides. So I'm going to go ahead and figure out what is the side length. So I'm going to take 40 equals 4S, and then we'll divide by 4. So the side length here is 10. So right here where I have side times side, I am going to replace that with 10 times 10. So I have 500 equals 1/3. 10 times 10 is 100 times the height. Well, let's type in 1/3 times 100 and see what we get. And we should get 33.3. Whoops, times the height. So 33.3 H. So now we'll divide by 33.3. So 500 divided by 33.3 will give you a height of 15. And your units are inches. Number 7 is very similar, except for it uses the concept of circumference instead. But circumference is just 2 times pi times the radius. So the circumference for the base of a cone is 8 pi. So all they did right here, you guys, instead of typing 8 times pi, they just left the pi alone. It says find the height of a cone if the volume is 96 pi. So same thing here. They did the volume, they just didn't type the pi through. Well, I cannot find the volume of this cone until I know the radius, because the area of the base is pi times the radius squared. Well, I can't do this volume until I know what the radius is. So I'm going to use the circumference formula. 8 pi equals 2 pi r. What I'm going to do here is divide both sides by 2 pi, because the pi here will cross out with the pi here. 8 divided by 2 is 4. So this particular cone has a radius of 4. So then over here for volume, I'm going to plug in 96 pi. For my radius right here, I am going to plug in 4. So I'll have 1/3 pi times 4 squared. So that's what I'm going to type into the calculator right now. 1/3 times, and actually I'm going to leave pi alone. So I'm just going to do 1/3 times 4 squared. And I'll get 5.3 pi times the height. The reason I left it alone, you guys, is because now when I go to divide, I'll divide by 5.3 pi. This pi here should cross out with that pi right there. So I just need to type in 96 divided by, and I'm going to hit second answer. Basically, it'll copy and paste what I just had typed in there. And I get that the height here is 18, and my units are, there are none. So I just have 18. Now you should have gotten basically the same thing if you just did 96 divided by 5.3. You would have gotten 18.1. So we would have been off by just a smidge, but it would have been close enough. Okay, so last slide here. So we have some couple more application examples. So a cylindrical swimming pool is 12 feet wide and 4 feet deep. So here is our cylindrical swimming pool. If it's 12 feet wide, then from here to here, that whole thing is 12, and then the height is 4. What is the volume of the swimming pool? Well, volume is area of the base times the height. Well, the base is pi r squared times the height. Well, it says it's 12 feet wide, so that's how wide it is. That's not the radius. The radius goes from the center out. So think to yourself, if I'm 12 feet wide, what would the radius of my pool be? So if you were thinking half of 12, you would have been correct. So your radius here would be 6 feet. So I'm going to do pi times 6 squared, and we're 4 feet deep, so then I'll do times 4. So let's see what we get. We type in pi times 6 squared times 4, and our volume is 452.4. And our units are feet cubed. So then how many gallons of water does it take to fill the swimming pool? So 1 cubic foot is equal to 7.48 gallons. So I am going to take the 452.4 and multiply it by the 7.48. So 452.4 times 7.48, and we get 3,383.95. So I'm actually going to call that 3,384 gallons. All right, last problem. It says the Pyramid Arena in Memphis, Tennessee is about 90 meters tall and has a square base with a side length of about 180 meters. So I'm going to attempt to draw a pyramid. All right, so we have a height of about 98, and these square bases here are 180. A prism-shaped building has the same square base as the Pyramid Arena. So there is a prism-shaped building somewhere with the exact same base as the Pyramid Arena. What they want you to do is figure out what the height of the, so what is the height of the building if it has the same volume as the Pyramid Arena? So what we need to do first, you guys, is figure out what is the volume of the pyramid. So 1/3 area of the base times the height. Well, the base is going to be 180 times 180, and then the height is 98. So let's type that in. So 180 times 180 times 98. And then 1/3 is essentially dividing by 3. So I'm going to go ahead and hit divide by 3 here. So the volume is pretty large. It's 1,058,400. All right, so then what we want to do is figure out what the height of this prism is that they're talking about, as long as it has the same square base. So we're going to take the volume we have here. The base is going to be 180 times 180, but the height we don't know. Again, the reason I know the area here, the capital B, is 180 times 180 is because it's the same as the B here, because they share the same base in common. So let's do 180 times 180. So we get 32,400. So then we'll divide by the 32,400. And that will give us what the height of this other building is. So 1,058,400 divided by 32,400 gives us 32.7. And our units are meters. All right, so these are, again, examples of backwards volume problems where you have to find a dimension based off of the given volume and just work backwards from there. So take some time and practice these and ask us questions if you have them. Thank you.